This is for Year 12 Specialist. It comes out of question 22 in 6F concerning parametric equations. Okay, well, I've got a head start on this question. If x equals sec t, then sec t is 1 on cos t. So the derivative dx dt will be negative cos t to the negative 2, then the derivative of cos, which is negative sine. The sines give you a positive sine t on cos squared. If y equals tan of t, then dy dt will be sec squared, which is 1 on cos t squared. So dy dx will be dy dt times dt dx, which gives you this. So if I'm looking for the equation of the normal, then I'm going to be saying that the gradient of the normal will be negative sine t, because the gradient of the tangent will be 1 on tan t. And I'm doing it at this point here. So I'm going to say y minus tan t equals m, which is minus sine t, x minus sec t. And do a little bit of simplification. Y will equal minus sine t x, negative negative, plus sine t on sec t is 1 on cos, so cos t. This minus becomes plus tan t, so I get y equals minus sine t x plus, that's tan 2 tan t. That's beautiful. If I'm now going to look at part B, the y-intercept of this will be equal to 2 tan t. The x-intercept, well, 0 equals minus sine t x plus 2 tan t. I've got negative 2 tan t on negative sine t equals x. Negative 2 sine t on cos t with a negative sine t on the bottom. The sine t's cancel, the negatives cancel, x equals 2 on cos t. If I'm looking for the triangle that goes from the y-intercept to there, then that height will be the y-intercept, which is 2 tan of t. The x-intercept is 2 on cos of t, so that will be 2 on cos of t. So the area should be a half times the base, 2 on cos t, times the height, which is 2 sine t on cos t, and that's going to equal, 2 cancels with 2, I've got 2 sine t on cos squared t will be the area. So that's 22A and B.